Phil, come on down. It's going to be our next in-person presenter, so I'm excited. So Phil Eichmann's a co-founder and chief experience officer here with us at Einblick, where he leads our UI and UX team. He holds a PhD in computer science from Brown University and a bachelor's degree in computer science from the University of Applied Science in Rapperswil, Switzerland. Nailed it. And prior to Einblick, as part of his dissertation, he was investigating visual methods for exploring and forecasting time series data. All right, Phil, the floor is yours.
All right. Yeah, thanks, Tim, for the introduction. My name is Philip Eichmann. Like he said, I'm a co-founder and CXO at Einblick Analytics. We're still kind of a small startup, very young, almost fresh out of MIT and Brown University. Today I'm going to be talking to you about Einblick's approach to collaborative analytics. So at Einblick, we work with various organizations who try to leverage their data faster. That's always kind of the key goal. And to do so, as we heard in a lot of talks this morning, people need to collaborate. So different teams within the organization need to come together and work on analytics together. To give you sort of a simple example, a question maybe at your organization comes up with a question, and then that person wants to get not just some random answer, but the answer should be data driven. So it needs to be sort of grounded in data. And now to get actionable results really quickly, what people need to do is to collaborate. So people need to come together. That person needs to reach out across different departments within the organization. If the question is sort of like business related, for example, why do our customers churn? Maybe that person should talk to the data science team, the data engineering team, data engineering experts to get the data and develop algorithms or use tools to read sort of an answer from the data. Then it might also be good for that person to talk to sales and marketing, because they might have some additional information that the data people don't have. So there's a lot of sort of communication between domain experts as well as more technical people when trying to answer a question like this. Now, this all sounds all great and sort of like simple in theory, but in practice, it's actually really slow. And this is kind of the key problem that analytics in theory is kind of simple, because we have the tools, we roughly know where the data is, but then we need to connect people in order to actually get to the answers. And now the reason or the three reasons why we think at Einblick this whole process is really slow is for one, it's really hard to align people on a data problem. So a lot of people have different backgrounds, different expertise. They don't speak the same language. And this is kind of the sort of the core, that there's no common language that kind of works across all different disciplines or different expertise levels. And that leads to delays. It leads to delays, especially because people need to sort of schedule in-person meetings, for example, or Zoom meetings to educate people on sort of the vocabulary that's used to answer a certain question. That all takes time and sort of delays slows down the process. Then the second reason that we think is really critical is that the entire analytics lifecycle requires the use of a lot of different tools. So it's not just one tool that people can use and learn, but they actually have to switch between different tools, and that leads to obviously to delays, because people have to be educated on different tools. Context switches are kind of expensive in terms of time, etc. Then lastly, anytime you want to solve sort of or answer a real world question, typically you work with big data. And big data, as we all know it, is cumbersome and slow to work with. So running sort of simple analysis on a small spreadsheet is easy, but if you want to actually run this on real world data, it gets much more cumbersome because you push a button and you're going to have to wait until the result comes back, which can take quite a while. Now, in the next few slides, I kind of want to show you what we do at Einblick Analytics to simplify that process and to actually facilitate collaborative analytics. And then in the second part of this talk here, I'm going to give you a demo to show you how we envision people work with collaborative analytics in the real world. So the first solution, or the solution to the first problem, aligning different people from different teams, the way we think about this is that we build sort of a video-enabled data whiteboard where the only thing that people have to do is to share a link, and then they can connect to the same sort of data space and collaborate on problems. So here in this video, you see that there's 3 connected people. There's one common language that they use, which is this visual language where they can lay out operators, they can create visualizations on the fly, everything updates in real time, they can chat through video or text, and sort of be immersed into the same world without having to compile PowerPoint slides to convey a simple message. Then let's move on to the second problem. The second problem is the analytics lifecycle that requires a lot of tools. And so sort of the key problem there is that there's different stages typically in an analytics workflow, from gathering data to preparing data, exploring it, building models. And each of these steps has sort of specialized tools. Now, when you think about sort of what happens in the real world when you tackle a new data problem, you might start out with cleaning the data in Trifacta or an application similar to Trifacta. Then you move on to something like Looker or a ThoughtSpot to visualize the data. And as you're visualizing it, you might realize that, oh, there's still, the data is still dirty. I need to go back to Trifacta, clean it some more. So people switch back to Trifacta, go back to ThoughtSpot again, and then eventually with that clean data, once they have sort of a bigger or better understanding of what's in there, start thinking about more complex questions, such as things that would involve building a model with H2O, for example. So all of this causes a lot of friction. And at Einblick, what we our mindset is slightly different. We think that, or believe that, the time it takes to get to an insight is much more important than specializing in one of these areas. So rather than overly optimizing for any of these particular areas, we really focus on allowing people to iterate fast between these different phases. Yeah, and lastly, maybe just to explain what there's a Swiss Army knife. This is sort of the key thing. We envision that our tool is kind of the go-to tool for all of these tasks, and let people collaboratively iterate on all of these phases. Now, the third problem, big data and complex computations. So the core problem here is that data is big, and the computations, if you try to build a model on a large data set, it'll take a lot of time. And now a lot of the co-founders within our company, we have a lot of experience in progressive computations. And the core idea of progressive computations is that users get a response really fast. They don't have to wait for the complete accurate results right away, but they get an initial response very quickly, so they can sort of get an initial idea of, does the data look right? Maybe I messed something up in the configuration, so can easily respond. And all of this, a lot of work from our co-founders actually went into sort of the researchy part of this area, and now we build it into the tool so that users actually always get a really fast response when they initiate some action. And to illustrate this, how this works in our tool, I'm going to play this video. So on the left-hand side here, before I play, just to quickly explain it, on the left-hand side, you'll see the progressive version of our tool, where you see a user interacting with the tool, and then in the lower part, the visualization updating based on the user interaction. On the right-hand side, you see the exact same thing, but this time without the progressive engine activated. And let me play this real quick. It's a time lapse, so you'll see a timer popping up. Here, a user selects something, then the visualization down here updates pretty much immediately, and it is refining over time. So you see, if you look very carefully, you see that the visualization is actually updating. And now, on the other hand, on the right-hand side, we're still waiting for results. We're at like 6 minutes, 7 minutes, still ongoing. No results. And then after 9 minutes, we kind of stop the animation. So the right-hand side kind of illustrates how data science usually works with other tools. It would be the Jupyter Notebook or your own Python script locally. If you run an operation on a large data set, you'll have to wait. And this is kind of the thing that we want to move away from with our approach, to always make sure that users get immediate feedback whenever they execute an action. All right. So this is it for the sort of the first part. But the second part of my talk is an actual demo of Einblick. So in the next, we probably don't have like as much time anymore, but we'll try to be brief. In the next 10 minutes or so, we'll give you sort of a walk through the tool to give you a sense of what you can actually do with it and how fast you can use it to get insights in your data. So let me start off with the application itself right here. So on the left-hand side, you'll see that there's two things underneath data frames: promotion leases and current leases. So for the sake of this demo, what I want to do is I want to kind of walk you through a scenario where we analyze a data set containing promotion leases. On the right-hand side, what you see is basically just an empty canvas. And that's sort of the premise of the tool, is that there's a lot of space that you can use to lay out your analysis. So I'm going to start off by dragging out this promotion analysis table onto the screen. And what appears is a table that shows you the content of this data frame. And now to give you a quick sense of what's in there, you see that there's some demographic information here: age, whether or not the person is married, the credit score, and then more sort of a promotion related information, such as what incentive was that customer given, and did that customer accept the promotion that he was given. Now, if I open up that data frame here on the left, I can see all other attributes, basically the same attributes as you can see here in the table as well. So the first thing that I want to look at in this data set is how many people have accepted our promotion versus how many didn't. And to do that, I can drag out this accepted attribute onto the workspace. And by default, the application will create a visualization for you. In this case, just a simple count histogram. So if you hover over it, it gives you sort of a quick glimpse into how much data is in here. So roughly 60% of our customers apparently did not accept our promotion versus the other 40%. As I'm interacting with the workspace, you probably notice that I'm moving things around here quite a bit. You can sort of freely arrange these operators on the workspace. You can zoom in, zoom out. So this is sort of really sort of free-form ideation slash data analysis tool that gives you all sort of the tools that you're used to from other free-form applications such as Miro and Figma, for example. So the first question that I want to answer here is that is there some signal in the data that would indicate subgroups of customers that are more likely to accept our promotion? So to do that, I'm going to drag out this age histogram to see whether or not potentially accepted is correlated with the age of a customer. Now, I can use sort of the visual tools, the charts here on the workspace to formulate queries. And in order to do that, I can drag out this link here, drop it onto age. And now if I change a selection in this visualization, this will basically update any downstream visualizations based on the selection. So let's say I want to filter this age distribution down to just the people that accepted the offer. To do that, I can click. And now if you look carefully, if I toggle back and forth, you see how the downstream visualization updates. So this is now showing me just the distribution, the age distribution for people that had accepted the offer. And we build in a lot of like little helpers that make it easier to discover certain phenomenon. So for example, instead of actually filtering this chart, I can switch or change the mode of this link to brushing. If I click, then you'll see that instead of filtering, now the selected population up here is highlighted. And this allows you to sort of get a sense of what does this subpopulation here look like in context of the entire population. And what becomes apparent when you look closely is that apparently our promotion did not work very well for the younger customers between 20 and 25 years old. And then if you look really carefully, if you zoom in a little bit, you see that actually for older customers, we see sort of the opposite phenomenon. Again, there's like a little checkbox that you can click to normalize this view to make it a bit more apparent that there's a difference because it's such a small bar. If you normalize it, then you clearly see that there's sort of a winner in terms of age groups that are likely to accept our promotion, which are people between 80 and 85 years old. Now, as you can imagine, I can do this for any of these attributes. I can add more filter predicates by just connecting visualizations very easily. But for the question that I'm trying to answer here, this might be a bit too cumbersome, even if you do it visually. This would be sort of a good point to bring in an expert that might help be able to help me or help find a better way of doing this kind of analysis. So what I'm going to do is I'm going to oops. Small here. What I'm going to do is I'm going to call in my colleague who's a data science expert and might be able to help me out with the next steps. So up here, there's a go live button that I can click. And if I launch it, this will basically set up an audio and video stream. And now I can simply share the link that I have here to my workspace with my colleague and wait for him to join the workspace. So I'm going to add it here, send it to him on Slack, and then hopefully he'll be here momentarily. Perfect. So looks like there's a new user that got connected. Just waiting for him to come live as well so we can actually chat. All right. Hi, Benedetto. Good. Thanks for joining.
Yeah, no problem.
Awesome. So Benedetto, I'm looking at this promotion lease data set. And basically what I'm trying to figure out is what are sort of the discriminating attributes between people that accepted the promotion and didn't accept the promotion, because our marketing team wants to improve that promotion a little bit. I started off with visual analysis. Do you know any other way how we can do this maybe a bit more systematically?
Yeah, sure. What we can do is maybe try out the key jar analysis operator so that we can find differences between people that accepted your promotion and did not accept. So let's set it up. So if you track me, I'm here at the bottom of the canvas.
Awesome. Yeah, let me observe what you're doing.
So it seems that the data that you want to use is this accepted attribute.
Yes, exactly. Yep.
All right, so let me duplicate this. And so what we're going to do here is just to give as a test population, so the guys that we care about accepting the promotion, and the ones that did not accept the promotion as control population. And so in this way, we'll be able to find differences between those two groups. So the result that you're getting on the first column, you have the pattern, so the insight that you're looking for. And then the second and third column, what's the percentage of people that have this pattern? And then the last one is just difference.
Gotcha. Okay.
If you want to have more insight, you can click on any button and a flashcard would pop up to explain you what the number means.
Fantastic. Great. Thank you. So it looks like credit score and age seem kind of um, important factors when it comes to who will accept the promotion. Let me just click on this. So this explains sort of in prose, in like actual text, how to read this number, how to interpret it. And we'll look at this again in more detail later on. For now, I'm just going to put this on the workspace so I have a reference to it and maybe create a quick bookmark. So I'll find it later on.
All right.
Thanks, Benedetto. That's great. Yeah, so as a next step, eventually what we want to do is we sort of want to be able to tell, based on customer attributes, who will be likely to accept our promotion. So I was thinking, since you're the expert in data science, maybe you could help me sort of set up a machine learning pipeline so that we can perhaps train a model that can infer whether or not someone will accept.
Yeah, sure. So we can use the AutoML. Actually, it's pretty straightforward. What I'm going to do is just select the AutoML operator from the left menu. Maybe we can do this together in a way that next time maybe you can also do this analysis on your own. But so your data is the promotion list one.
Exactly. Yep.
To use as a train.
Right.
Yeah. So what I'm doing is just to provide the train data to the algorithm, and then as a target variable, which one do you want to use? Accept it.
Yes, exactly. I want to predict whether or not a customer will accept a promotion.
All right. So let's select that from the menu. And then as a feature, you want to use all of them?
Yeah. Oh, maybe you remove the bottom two ones.
All right. So let's do that. As metric, let's just use accuracy. So I'm going to set the AutoML just real quick, just for the sake of results, and then I can refine this for you. Or maybe you can do it on your own later on if you're interested.
Perfect. Yeah, let me just quickly explain what's happening here. So Benedetto set up the problem for me. We want to predict whether or not a customer will accept the promotion based on historical data. Benedetto set up this AutoML operator very quickly, set the target, set the features that we want to let the model look at. And now new results are being streamed in. So this graph basically shows you pipelines that are being streamed in from the backend. Each dot here is a model that can be used to actually predict whether or not a customer accepted the promotion. So Benedetto here drags out a pipeline from this graph. Apparently, this model has an accuracy of roughly 86%. And this was trained within seconds, right? We didn't wait for a long time. Pretty good accuracy after just a few seconds. And now, Benedetto, maybe you can quickly give us some insight into that particular model. Maybe there's some interesting characteristics that you want to point out.
So if you take a look to the explainer that I just dragged out, seems that the three top most important attributes to make the prediction are incentive, age, and the remaining length. So I guess for age and remaining length makes sense. Also for incentive, is this something that match your expectation here?
Yes, maybe. Yeah, that's great. Maybe just to give you sort of a good counter example, apparently all the way at the bottom, there's attributes that apparently don't matter for this model. So it doesn't matter whether or not you're married or employed, you will be more likely to, or equally likely to accept the promotion. And these are kind of interesting insights that domain experts can, derive themselves very quickly, very easily, just to prototype a model and see whether or not the model is actually looking at the right data, whether there's bias in the model that you feed into a data, and so forth. Just to wrap up, I know that I'm going over a bit. Just to wrap up, all of this functionality is, accessible through this visual UI. There's lots of details where actual data scientists or people who know how to code can contribute to the platform and expose their own primitives, so to speak, in the platform. So people can write their own Python operators. They can build their own operators that we have here on the list. So this is basically just sort of the native ones that we have in our platform. If users want to run their own models within that platform, that's easily doable. They can also take sort of a model that our system found, download. Where are we here? Download the code export the code from an existing model, and then maybe tune it offline and hand it off to someone who knows more about programming. Like I said, there's lots of other features. We're more than happy to talk to you. If anyone is interested in the platform, I'm more than happy to give you a more detailed demo. There's lots of information on the website too. The last thing that I want to do is just to quickly point out, do this real quick. If you go to our website, there's a Try Einblick button. We have a 14-day trial that people can use to test it out on their own data. It's not feature limited. You can use all of the features that are available in the platform. And yeah, it would be great if you give it a try. And like I said, I'd be more than happy to give you a more in-depth demo later on. Thank you.